Hello and welcome to the video notes for Chapter 9, Lesson 1, Developing Formulas for Triangles and Quadrilaterals. Our objectives today, you can see here on the screen, are going to be develop and apply these formulas for triangles and special quadrilaterals, and we will also be using those formulas to do problem solving. So let's get started right away. And here's your warm-up. We're going to go through this pretty quickly, so if you need more time, pause the video. But you need to find what C would be, A would be, and what B would be. Those are the different sides of right triangles, so we need to be using Pythagorean theorem. Notice in number 1, you're given both legs, find the hypotenuse. On number 2, though, you're given one leg and the hypotenuse, find the other leg. Same thing for 3, you're given one leg and the hypotenuse, find the other leg. So make sure you're plugging those into the appropriate places in your Pythagorean theorem. Alright, let's go ahead and take a look at what our answers should be. For number 1, we should get that C is 29. For number 2, we should get that A is 28. And for number 3, we should get that B is 48. Alright, let's go ahead and take a look at this lesson. We start off with our area addition postulate, and so fill in the blanks appropriately. The area of a region is equal to the sum of the area of its non-overlapping parts. We're going to look at this a little bit more in class, but it basically allows us to set up some other formulas for area other than just rectangles and triangles. So like, let's say we have a parallelogram. The area formula parallelogram, you'll notice, is the same as the area formula for a rectangle by the same dimensions. Area equals base times height. Remember, the height is perpendicular to the base. Okay, so the area formula for a square is just side squared, and for a perimeter, for a square, it's just 4 times s. We will talk about the perimeter of a parallelogram again later in class, but we won't need it for this next example. The height of a parallelogram is measured along a segment perpendicular to a line containing the base. Remember, I just pointed that out a moment or two ago. And the perimeter of a rectangle with base b and height h is 2b plus 2h, or 2 times the quantity b plus h. That's perimeter of a rectangle. Okay, not a parallelogram, a rectangle. So let's take a look at example 1. In this first example, part A, we have our parallelogram that has one side measuring 11 millimeters and one side measuring 34. If we wanted to find perimeter, all we would do is add 11, 11, 34, and 34, and that's perimeter of a parallelogram. But this problem asks us to find the area. In order to do that, I have to know the height. Well, that's why I've drawn these dotted lines in. If I extend this 11 millimeter side out 30 millimeters more, I can get to where I can draw this height measurement from this side to that. The reason I do that is so that I can measure, using this as the hypotenuse, what that height would be. So we're going to use our Pythagorean theorem. So why don't you take a few moments, go ahead and use Pythagorean theorem to find h. H is one leg of the right triangle. This 30 millimeter dotted line is the other leg of a right triangle. And remember, this side of your parallelogram is 34 millimeters. So that's your hypotenuse of that right triangle. So we can say 30 squared plus h squared equals 34 squared. Again, I'll write that for you. 30 squared plus h squared equals 34 squared. So solve that for h, and when you're ready, if you haven't completed by the time I write the answer, pause the video, but when you're ready, continue. Alright, for this part, we should get that the height of our rectangle is 16. So if this is 16, we know our base is 11. We don't want to use the 34 for the base, we want to use the 11 for the base. So our area formula for a parallelogram, remember, is base times height. Well, we just found height is 16. We know our base is 11. So the area of our parallelogram is 11 times 16, which is 176 millimeters square. But we say that square millimeters. Alright, we're actually going to skip past part B of example 1 because we're going to do something very similar to this in part C. So let's go ahead and jump to part C of example 1. We'll come back and take a look at part B later on in class, but for the video, let's look only at part C. We are to find the perimeter of this rectangle. in which the area is given as an expression containing x. And so we have to do a little bit of work first. Here is what the perimeter formula of a rectangle is. 2 times the base plus 2 times the height. Well, in order to find the perimeter, I need to know the base and the height. We could call this 21 centimeter side the base, so we know the base. So our perimeter is 2 times 21. But we have to know the height. So we have to find out what the height is. Before we can do the rest of this, we have to find the height. Well, we are given the area. So you'll need to remember that the area formula is base times height. We know the base. We just said that's 21. So to find what the height is, we're going to say that base times height, 21 times h, equals our area, and we're going to use that, 79.8x squared minus 42. So to find out what h is, we're going to divide both sides by 21. And when we divide this right-hand side by 21, we're going to divide both of these by 21. So that we should get h equals 3.8x squared minus 2. So if that's my height, I'm going to take that and plug that into this perimeter. 3.8x squared minus 2. Now we can simplify and combine like terms to find the area. When you do that, you should get that the perimeter is 7.6x squared plus 38. And that is, in the units of measure, centimeters. So now let's move on to talking about areas of triangles and trapezoids. You'll notice these are very similar area formulas. We're taking half of the base times the height for our area of a triangle, and half of the bases times the height for a trapezoid. That's because a trapezoid has two bases. The two parallel sides are called the bases, and their distance apart is called the height. So these are those two formulas. So let's go ahead and put those into practice. Example 2a, we're going to find the area of trapezoid in which base 1 is 8, base 2 is 5, and the height is 6.2. Now it's a matter of just filling in what we know. So we're going to start with our formula. Again, area of a trapezoid is 1/2 sum of the bases times the height. So the area in this case is 1/2 8 plus 5 times 6.2. Okay, go ahead and answer this by simplifying. Remember your order of operations. You have to add 8 and 5, then do your multiplication. So we're going to do 8 plus 5 is 13. I'm going to go ahead and do half of the 6.2. Because that's an even decimal, I can do half of that and get 3.1. So 8 plus 5 is 13, and half of the 6.2 is 3.1. So I'm going to do 13 times 3.1. When you multiply those together, you get the area of this trapezoid is 40.3 square inches. All right, we're going to do example 2b, but not 2c yet. We'll do example 2c later on in class. We're going to do example 2b right now. We're given the base as b and the area as 15x squared, and this height of the triangle is 5x. They want you to find the base in terms of x. So again, we're going to start with our area formula. Area of a triangle is 1/2 base times height. Well, let's plug in what we have given. Instead of being given these two measurements and finding area, we are actually given the area in terms of x, 15x squared, equals 1/2. The base is still just represented as b, but the height is given to us as 5x. So there's a lot of different ways we could start to solve this. I'm going to cancel out the 5x first. We want to get b by itself. So I'm going to divide both sides by 5x. In doing so, 5x cancel on the right, but 15 over 5 is 3. And x squared over x, is just x. So what we get is that 3x equals 1/2 the base. Well, to find out what the base is, then we just need to multiply both sides by 2. 2 times 3x is 6x. So the base of this triangle is expressed as 6x squared. Sorry, 6x. We don't need the exponent 2. And that is a unit of measure given to us as centimeters. All right, let's keep moving right along. We also need to talk about rhombuses and kites. Remember that the diagonals of a rhombus or kite are perpendicular, and the diagonals of a rhombus bisect each other. Those are useful things when we talk about this. The reason we remember that is because in rhombus and kite area formulas, they're both the same formula, and it uses the length of the diagonals. And we can go over why that is in class, but for right now, we just need to use this formula to do our calculations. D1 represents one of the diagonals, D2 represents the other. It really doesn't matter which one you call one diagonal, which one you call the other. But we do need to remember that formula. So I'm going to write that in nice and bold up here. The area of a rhombus and or a kite is 1/2 the product of their diagonals, D1 times D2. So we're going to take half of that product. So in example 3a, we are given one diagonal and the area and asked to find the other diagonal. So we set up our equation to match this formula. We know the area is 238, so we fill in that for a, and we can do half of diagonal 1. Diagonal 1 is 14, and then do diagonal 2 as d2. So this is what we want to find. Let's go ahead and do half of 14 first, just simplify that. 238 equals 7 times diagonal 2. Half of 14 is 7. So now to solve for diagonal 2, we just divide both sides by 7. In dividing both sides by 7, you can see that the diagonal 2 that you're asked to find is 34 inches. All right, we are going to go ahead and we'll look at example 3, B and C in class, but I do want to make sure we have time in the video to talk about example 4. So we're going to skip B and C, talk about those again in class, and move right on to example 4, applying what this might look like in some kind of pattern of shapes. So we have a tile design here made up of these different shapes, a bunch of triangles put together, and it makes a rectangle. The base of the rectangle is 4. The height of the rectangle is 2. What that tells me is that each little segment is 1 inch in length. We're going to use this grid to find the perimeter and area of the leftmost shaded region. It means I'm talking about this shaded region. Okay? So let's look at what we can call the base and the height of that shape, because that is a parallelogram. Well, let's say I called this vertical side the base. That's a length of 1. And the height measurement, we could call that a length of 1 as well. So we have a base and a height that equal 1. For the perimeter, though, that's the distance around the edge. So I'm not going to be able to find my perimeter using these two. These are going to help me find the area. Remember, area of a parallelogram is base times height. So the area is 1 times 1, or 1 square inch. The perimeter, on the other hand, we need to know what this measurement is. Well, if you look, that's the hypotenuse of a 1 by 1 right triangle. And these are 45, 45, 90s triangles, so the hypotenuse is √2. So the perimeter is 2 times the base plus 2 times the other side. We'll call that C. So that's 2 times 1 plus 2 times √2. And we can simplify that to just 2 plus 2 √2 inches.